sit in the right spot. Otherwise, we can't use them anymore. Now, I know the last couple days I've just let you grab one, and this has been really good about touching back. But from now on, when you pick up them, make sure you get your number. Okay?
So, like, should we go ahead and trade, or?
It's okay to. Let's not
Okay.
get it again. Yes.
What if you have your own?
Then you don't have to do one.
Okay.
You're good. Even better. You don't have to do that.
Yeah, of course. Where did you get it?
Where'd I get it? I don't know, my dad got it.
Go
They
stand
have
by
them at
one.
Staples.
Well, I went there and never out.
Apparently, got them back in inventory.
I got it on Sunday.
Oh, well, I went after that. So,
I'm a lazy mama. If they ask me for something that's hard to find, I just order it off Amazon and I don't have to go look for it. 2 days shipping. Any questions about 1 through 4? I'm gonna be excited. None? Alright. Alright, let's move on then. Okay, 5 and 6. Let's take a look at those. Now, I like my answers in exact form. So I'm not going to change this to a decimal. I'm going to leave it as negative 80 thirds. I guess you could switch it to, what is it, negative 26 and 2 thirds? And the reason I do that is because the higher you go in math, the more steps your problems have. And if you round at the first part, by the time you get to your answer, you have allowed a lot of room for error. So we leave everything as an exact answer until the very, very end. And at the very, very end, if it's a word problem, then you might want to round. Do what makes sense in terms of, in context of the problem. If it's just a pure math problem you're solving, leave your answers in exact form, unless I say round your answers to the nearest whatever. Okay?
Why'd you multiply by 20?
I chose to eliminate my fractions. That's what I taught yesterday. You did not have to do it that way. So the common denominator for 4 and 5 is 20. So to eliminate my denominators, if I multiply each term through by that 20, it makes the denominators go away. So negative 1 times 20 is negative 20. 4 goes into 25 times, and 5 times x is 5x. 3 times 20 is 60. 5 goes into 20 4 times, and 4 times 2x is 8x. And then I have a simple equation to solve that has no fractions. Yes, sir?
oh, wait a minute, this one.
Okay.
Yeah, I got it now.
All right. Okay, now in a previous class, somebody asked me if this is the correct answer. You guys tell me, is this the correct answer?
Yeah.
Yes. These two mean exactly the same thing. This says negative 4 is less than or equal to all the answers. This says all the answers are greater than or equal to negative 4. Do those two things mean the same thing?
Yes.
Yes, they do. So those are both true answers. All right, let's take a look at number 7. See if you have any questions.
So you're saying we should leave them in fraction form instead of decimals?
Unless my directions say round your answers to the nearest whatever,
Okay.
then just leave them at an exact form. Yes. Is negative 3 divided by 13 the same thing?
Yes, ma'am.
Okay, good. Okay, now, last period, somebody said, is that the same thing as negative 13 over 3? And after I finished crying, I said no. Because when we're solving for this, we're solving for x. So to get x by itself, what has to move? The 13. So we would have to divide by the 13. So x equals negative 3/13 is the correct answer. Are we good? Alright. Number 8. Now, I chose to eliminate the fractions. Here are the fractions. So the way I did that was I looked at the 5, the 3, and the 2, those are my denominators. What's a common denominator for 5, 3, and 2? Well, 30. So if I took and multiplied every single term by 30, so that it remained a balanced equation, then I could eliminate, because 5 goes into 30 6 times. 3 goes into 30 10 times. 2 goes into 30 15 times. 3 goes into 30 10 times. So 2 gives me the 12x. And then 10 times 1 is the 10. 15 times 1 is 15. 10 times 2 is 20. Does that make sense? Now, both of these are exact answers. I'd accept either one. Negative 25/8 or 3.125. Those are both exact. What would change if this were an approximate? What would I do right here if it was an approximate? Yes, we would put the squiggly lines. Alright, take a look at number 9. See if you have any questions about number 9. Then we're going to talk about number 10. Any questions about number 9? Alright, number 10 had 3 people in it. Jake, Anna, and Kyle. My son, my daughter, and my hubby. Yes.
Never mind.
Alright. Well, we were saving for a trip to go to Disney World the year I wrote this worksheet. So it was about going to Disney World. And it says Anna has $30 more than Jake. So Anna was in terms of Jake. So we're going to let Jake be represented by J. And now I can rewrite all the other characters in this story in terms of Jake. Because Anna saved $30 more than Jake. And Kyle saved 5 times as much as Anna. Well, Anna is represented by 30 plus Jake. So Kyle did 5 times 30 plus Jake. So when I took everything that Jake saved, plus everything that Anna saved, plus everything that Kyle saved, that equals the total amount of money I saved for the trip. So when we add these up and solve, we solve for J, which is the amount of money that Jake saved. And Jake was a little thing then, so he had only saved $13.
So is this like a true fact?
They did save their money to go to Disney World. Yeah. But we didn't make them buy their own tickets. They used that to buy, junk. Balls that they lost before we got home. Pins that broke in 2 days. Good stuff. Those lollipops that are like bigger than their head. Okay. Any questions? Okay. Number 11. Somebody in second period did not like this problem because it said find the error, but there were 2. Yeah, there were 2. Didn't distribute correctly. Isn't that like the 5th one I've given you where they didn't distribute correctly?
Correct.
What do you think y'all miss more often? Distributing. It's that negative on that second or third when we distribute that it just gets neglected. So I really want to make a point at the beginning of the year not to do that. So here we go. This should be plus. So that's where the first error occurred. They did use the distributor property, they just didn't use it correctly. And then they combined like terms. Then they use the subtraction property of equality here. They use the addition property incorrectly here. And then they use the division property of equality. So we have 2 issues. This should be positive, and this should be subtraction, not addition. So if this person had done it correctly, they would have gotten negative 1/4 equal to x. How'd you do? Yay! Okay, now the last 2 were those weird types of problems we talked about yesterday. What happens when the variables cancel? And that's what happened on the 12 and 13. Okay, so on 12, we distribute, then we combine like terms, then we use the subtraction property of equality, and our variables went away. So now we're left with statement, negative 15 equals 2. Is that true? No, it's not true. Negative 15 does not equal 2. So there is no solution to this problem. And then the next one, we distribute the negative, we combine like terms, we use addition addition or subtraction properties of equality, and we get 6 equals 6. So, x could be any real number, and it would work. So if you want to write infinitely many solutions, that's fine. Any questions on 12 or 13? You guys are rocking it today. I'm feeling like you're going to have time to work on your homework. Okay, today is a learning task. It's a 2-part learning task. The first part is about a yo-yo, and the second part is about pennies. Now the second part says you can sketch it, but we don't need to, because I'm a math teacher, so I have a bag full of pennies. Alright? We can use pennies for lots of things for math. So we're actually, each group can grab about 20 pennies is all you'll need. And you can do the designs on your desk, and you do not have to sketch them when you get to that point. You may work in groups of 2 to 4.